All right, in this video, let's go ahead and dive into the OSI model and discuss the 7 layers. So in the previous video, we talked about the use case for the OSI model. Where did the DoD TCP IP come from? That was way before the OSI model. But when the web got a little bit more complex and many more manufacturers started to develop devices, we needed something to standardize. And so really, the OSI model just really extends the DoD TCP IP model. But here's the OSI model, and it's 7 layers. And so let's just talk about each layer. And this is another graphic I pulled off of ChatGPT, and I thought I did a good job. And it's kind of showing the transmission of this image file when you go to a client, let's say a browser, whether it's Google or Firefox, whatever it may be, how it actually transitions through these 7 layers. So the first one here, well, we're going to start from the top and then work our way down. And let me pull up my pen here. So the application layer, layer 7, it works with specific networking applications such as a web browser, whether that's Microsoft Edge, Chrome, Firefox, Brave. We're all familiar with. We use browsers daily. Or file transfer programs, like there's a popular one called FileZilla, or in your school issue email account like Outlook or Gmail. These are all interfaces or applications that we can interface with the particular network. And so some of the popular protocols here is HTTP, and you'll see HTTPS, that stands for Secure Socket Layer, and this essentially has to do with the encryption as data is transmitted. And then FTP, there's SFTP, File Transfer Protocol, WWW, and then POP, IMAP. Those have to deal with like the email protocols. But then again, the basic thing about the application layer is the actual they're the applications, the networking applications that we interface with, the end user actually engages with. All right, the next layer is layer 6, which is the presentation layer. You'll see that it says translates, compresses, and encrypts data. But what does that really mean? A really simple way of thinking about this is that it's the translator or formatter. And I'm working through this backwards, but layers 6 and 7 work together, right? So we have to format it or translate what is coming from the network to display, if we're using this image, to display this image within the browser. And so layer 6 makes sure data is in a format the application can understand. So there's something called UTF-8, there's Unicode, but it's the idea that we can, it's responsible for converting character codes into a code that's recognizable by a computer that uses a different character code, if that makes any sense. And so essentially it's the idea of translating, and also I would say there's a level of encryption that happens at this layer as well. All right, the next layer is layer 5, which is the session layer. And the easy way of thinking about this is that it's the way 2 devices communicate, right? It's the session level. It manages the conversation. It's starting the conversation, keeping it alive, and then ending that conversation cleanly. And then it can resume if there's any interruption as well in that particular communication between those two devices. And so, the way that I would illustrate this here is like a phone call, right? And so you would say, let's say layer 7 says, what you say? Layer 6 would say, what is the language you speak, right? And then layer 5 is like dialing the number, staying on a call, and then hanging up, right? And so that's what its job is to do, is to maintain the actual session between the 2 different devices. All right, so the next layer is the transport layer, layer 4. And so it ensures reliability, end-to-end delivery, segments data, flow control, transport packets error check. So what does this actually mean? In simple terms, what it does is, like I said, it's responsible for the end-to-end communication, the transportation, or the delivery of data. So it breaks data into these chunks, which is what we would call segmentation. And then it puts data back together, reassembles them, but it also reassembles them in the right order. And so, like, to get a little the technical language that we'll dive into a little bit later in this course, you'll hear a term called packets, right? So packets are transmitted over many miles and may use different routes. And we're going to simulate this in some of the other videos that I'll record. But the packets may not arrive in the same sequence in which they were transmitted. And so what happens at this layer is that they have to be reassembled into their correct order. And there's terminology that we'll discuss in terms of how that all happens. So from segments to packets to frames, and we'll discuss that, right? But the whole point of this layer is dealing with end-to-end delivery. It uses ports to reach the right app, and it also ensures reliability and order. And so that's the TCP part. And then speed has to do with the port UDP. And so you'll see the protocols here is TCP UDP, and we'll dive a little bit deeper into these more specifically. But anyway, it's the end-to-end delivery ensures reliability, and it does that through breaking down data into chunks. That's the segmentation, and to these packets. But then it has to reassemble, puts the chunks back together. And then it also helps prevent, overwhelming the receiver as well. So that's the transport layer. The next layer here is the network layer, layer 3. So at the network level, it's the primary responsibility is for addressing and navigating networks by using generated IP addresses. And so essentially, it's deciding where data needs to go and how to get it there. You kind of think of it as it's like the GPS of the network. And so the question is you think about asking at this level is, where's the destination address? Is the destination on my local network or a remote one? And then which path should the data take? So as packets, as I mentioned in the previous transport level, so as packets are transmitted from one network to another, there's several different routes that can be used. When you think of the network layer, think of navigating between networks, right? So it's really ultimately it's the GPS of the network, if you want to think of it that way. So where does my data need to go, and then how do I best get it there? I would also like to mention that any device, let me say this, routers are a good example of devices operating at this level. So any device that directs traffic based on the IP address is operating at the network level. So keep that in mind. And that's one of the major protocols of this particular layer. All right, 2 more layers to go. The next layer is layer 2, the data link layer. This layer, it prepares data for the physical transport and adds the local address. So in the previous layer, the network layer, you're thinking about traveling from network to network. So it's dealing with the addressing and routing between networks. But the data link layer is dealing with, think about the local area network specifically. And its primary goal is to get data from one device to another on the same network. So it's describing how raw data is packaged to transfer from one network interface card to another. This layer also contains information such as the address of the source and the destination, we'll talk about the MAC address, and the size of the packet, and it also talks about, it produces error checking as well in this layer. What example can I give for this one? For layer 2, the best analogy I can give in comparison to the other layers, let's say that layer 3, the networking layer, it chooses the building, the IP address. Layer 2 is going to deliver the correct apartment. So we're localizing, we're coming closer to the local network, the MAC address, right? And then layer 1, which we'll talk about, which is the physical, is like the hallway and the wires, right? It's the physical pieces. The other thing I want to mention about this layer is that it consists of 2 sub-layers. One is what we call the logical link control, which is the LLC. And then we have the MAC, which stands for the media access control. And so the LLC, in short, it frames the content of the upper layers. And so it is placing all the data in an orderly sequence of ones and zeros. And then what the MAC does is it converts that frame into a series of like digital pulses that it'll send through the wires. And so we'll talk more about both of those, both sub layers that fall within the data layer, and how that functions. And then the last layer here is our physical layer. So before we dive into the physical, I also want to make mention is that at the data link layer, this is also where switches, in terms of network devices, this is where you would see switches performing their various tasks. So the physical, this is the lowest level, level 1. It transmits raw data as bits, zeros and ones over the physical medium, hubs, repeaters, cables, fiber optic, Wi-Fi. So not just the physical, but also the zeros and ones that are pulsating through, basically radio transmitted through Wi-Fi as well. So you're thinking about, at this level, you're thinking about the actual hardware. You're thinking about Ethernet cables, fiber optic cables, Wi-Fi radio signals, network interface cards at this level as well. So this layer is only concerned with how digital signals, the binary ones and zeros, are carried electronically from one network device to another. So the physical layer is where actual raw bits are transmitted. So we worked through this backwards, right? I started with layer 7, went to layer 6, and then all the way down to 1. And hopefully I gave enough analogies to kind of help you concretize this into your thinking. On the next slide here, I put together these activities here, and we're going to walk through this together in our synchronous session. But do your best to try to match the layer with the correct question that it's asking. So there's 2 of them. There's this activity here, and then I did another one that had different questions that will allow you to match. This one is actually incorrect. It's an actual layer, but I need to fix it because one of the layers actually will not apply. But I'll have it fixed hopefully soon here. Okay, this video is getting way too long, and we'll discuss more. We're going to dive deeper into the various levels or layers within the OSI model throughout the remaining weeks. So stay tuned.